lab view code that's going to operate the motors of the robot. The robot would proceed going forward, and it would stop due to data collected by the sensor. And when the robot stops, it will actually turn on our circuit, which contains a mic, various resistors, and a switch. The mic is going to take some data for us that's going to control the strength of the power of the motor that's mixing, and the switch is going to turn off the whole circuit. So essentially we have a circle of code that's operating the robot. The robot is going to turn on the circuit, and the circuit is actually going to affect the robot. So we have a full circle here. But now let's break it down.
So we've got our whole while loop, which will control everything. And inside that while loop, we've got here where it starts up our wheels, so they'll move forward. We also have we have it set to make sure our circuit's off. We don't want that to run yet. And we have our ultrasonic detector, which will detect the distance of something in front of the robot. And when it gets to something less than 10 centimeters or equal to, it'll activate our case structure. And our case structure, which is empty if it's false, but when it's true, we have a flat sequence which will control kind of our whole mixing process, right? So it'll start off by stopping the wheels, making sure everything's off. It'll then lower our mixer and turn on our circuit. Once that happens, it'll start mixing, and we have a couple arrays here which will collect data from our circuit. One, which collects data from our mic, and then we have another which is a timer, so we can keep track of how long it's going. Those two we bundled up, and we make it do a plot, which we'll see in a bit. Also from the mic, we have it going into this other case structure, which will control the power of our mixer. So when the voltage from our mic is above, a certain threshold, which is above the background and stuff and all that, it will take the power of our mixer and increment it by 10. And also with that, if it goes over 100, it'll subtract 100 off the value. So when it's at 100 and you add 10, it'll go to 110, then subtract 100 and be at 10 again. In addition to that, we have a switch in our circuit which controls when to stop this whole while loop. So hit the switch, this will deliver a 1, which will be a true, which will stop everything. Otherwise it'll be a 0, and it'll keep going. Finally, we have a couple displays. We have a power display, so you can see how powerful it's spinning, and our plot, which we'll see in a later part. After that, it stops the mixer and then lifts up the mixer, so it's in the ready to roll stance, and then stops the lifting and stops the whole thing. That's it.
So here's our circuit. So in essence, when the robot ultrasound detector is going to detect an object 10 centimeters away, our circuit's going to turn on. So our flexible input-output 4 of the lab jack is going to generate an input of 5 volts that's going to go through the circuit. Originally, our switch is going to be off, so you can ignore this part of the circuit for now. We're going to have current going through the microphone and the resistors. So we have a voltage divider, essentially. And the microphone is going to hear different sounds, and based on those sounds, it's going to increase or decrease its resistance. So then we will get different output voltages on our AIM2 through the lab view code, and then it will go to ground. Now, when we want to shut off the mixer, we will press on the switch, and then current 5 volts will go through to our FiO7, which when that happens is going to go to the 1 state in our code, and we'll shut off the mixer. So here is our Mixobot in live action. So as the code turns on, our wheels are moving, and we have an ultrasound detector that will detect the cup. Once it detects the cup, as you see, the motor is brought down and will begin mixing.
So here we have our data in action. We have the voltage from our mic and the voltage divider here. So when you turn up this, when you give it more sound, like I'll just hit it, you can see it spikes up, and that increases the power on our motor here on this display. So you can keep hitting it, keep powering it up, and when we get to max power, it resets back down to the lower level. And just like that, we can stop it with this switch here. And it lifts back up.
So from making Sir Mixobot, we've actually learned quite a lot here. Uh, we've learned how to code a program through LabVIEW that directly uh, interfaces with a robot here, or the EV3, and I thought it was really cool, and I didn't know that was possible at first, that whatever we do with the robot, like for example in our robot, once it pauses and stops moving, our circuit's turned on. So I didn't know originally that the circuit and the robot can interact, considering they're not connected through any way other than the LabVIEW code. So I thought that was really interesting. I had to refresh a little bit of LabVIEW, so that was a bit of a challenge, but definitely a new. I liked learning about the new Mindstorms feature, and it was really just fun to see it come full circle. And I think that was the biggest learning experience of all, just seeing how the computer interfaces with the robot and circuit, and how everything kind of connected.
So my biggest takeaway from this project was the power of being able to interact with the environment through a circuit, and then being able to send that into a computer and analyze that data and sort of use it to control other things. So we were able to control this robot, which you don't have to get up and press buttons to deal with. You can just shout at it, or hit the mic to make a sound, to make it speed up or slow down, and hit the button to stop it. I thought that was really cool.